Alright, so now we're going to do a probability question in which we're actually going to draw a tree diagram. Okay, so before you draw the tree diagram, you've got to be very clear what the experiment is. So it says there's a bag with 10 discs, 2 blue, 5 red and 3 green. Okay, so it's 2 blue, 5 red, 3 green with a total of 10. Okay, and the key thing here is that 2 are going to be taken out one after another without replacement. Okay, no replacement. So if I take out one disc and I put it one side, I would have a total of 9 left. Okay, so let's start doing the probability tree. So let's start at the center right here. So when I put my hand into the bag, I could only possibly have 3 colors. So that's why my first branch is actually 1, 2, then 3. So either I'm going to get a blue, a red, or a green. This is my first pick. Right? So now, when we do a tree diagram, we actually have to write down the associated probability. So very simple. First pick actually is, what's the probability of getting a blue? So the number of blues out of the total number. So we have 2 out of 10, which actually simplifies to 1/5. Okay, next, probability of getting a red. 5 out of 10, which actually simplifies to half. Last but not least, green, 3 out of 10. Okay, it doesn't simplify any further. Okay, and the thing happens here is that this is only the first pick. Let's say I follow this reality in which I pick a blue disc. What happens next is that I could again pick 3 things. 1, 2, or 3. Again, a blue, a green, or a red. Similarly here, if I had picked a red first, then I'll have either a blue, a green, or a red next. Last but not least, if I had picked the first green, then I'll again have 3 choices when I put my hand back in. Blue, green, or red. So what are the probabilities associated with these few in the second pick? So just now we said no replacement. So second pick, the total number of the probability is affected. For example, if I already picked out 1 blue in the first case, then I'll only have 1 blue left out of the new total number of 9. Okay, consider the second case. If I already picked a blue, then the red is not affected. So I still have 5 red out of the new total 9. Last but not least, if I had taken a blue, green is not affected. So 3 green out of the total new 9. However, this simplifies to 1/3. So I do the same for all the remaining branches. Bear in mind, when I do this reality, I had picked a red first. So blue is not affected, so 2 out of the 9 left. Green is not affected by the red, so I have a total of 3 out of 9, which simplifies to 1/3 again. Okay, then last but not least, if I had picked the red first, 5, so I only have 4 left out of the new total 9. Now down to the branch of green. If I had picked the green at first, blue is not affected, 2 out of 9. If I already picked the green, so I only have 2 green left out of the new 9. And last but not least, I would have 5 out of 9 here. So that's part A. Okay. So moving on to part B. What I will do now is I'll move the paper down and we'll see all the questions here. Okay. So I'll try to squeeze all the answers here. But first I'll write down everything here as outcomes. In this reality, blue, red, red, blue, red, green, red, red, green, blue, green, 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 red. How do I get these outcomes? Simply by, let's say this one, I picked a red and then a blue. So red, then blue. Okay, so now let's answer the first question, B part 1. Oops. What is the probability that both this will be green? So very simple, I'm just looking at one single simple outcome, which is the one over here. So for this to happen, I had to pick a green with probability of 3 out of 10, and then another green with 2 out of 9. So very simple, 3 out of 10, and then 2 out of 9, which gives us a value of 1/15. Simple. How about the second one? one disc is red and the other disc is blue. Notice that they did not specify the order. So it could be, what we're looking for is a red and then a blue, or blue and then a red. Both of these situations satisfy this statement here. So it could be red blue, which is, where's my red blue? This outcome here, with a probability of half and 2, 9. Or blue then red. Where is blue red? This one. So blue red is 1/5 and then 1/3. Oops. Don't mind that, a bit messy. And when I key this into my calculator, I would get a value of 2 out of 9. Simple. Now, the third one is the challenging one. They say, I just don't want the second disc to be red. Okay, so the first disc can be any color, second disc anything but red. And you realize that many of these situations satisfy this statement. So instead of doing that, of saying I just don't want second not to be red, I can look at it from the other way. Because I know total probability is 1, so why don't I do it by the way of probability of 1 minus the probability that the second one is red. Okay, because this is the total opposite of second one not being red, where the second one is red. So we realize this actually satisfies only 3 cases, which are namely 1, 2, and 3. Instead of finding 1, 2, 3, 4, 5, 6, the probability of that, instead I take 1 minus the 3 probabilities here. So it's simpler. So 1 minus probability of blue red, minus probability of red red, minus probability of green red. Okay, so individually I'll find the probability. So it's 1 blue red, okay, 1/5 times 1/3, minus red red, where's red red, okay, half multiplied by 4/9, green red here, 3/10 multiplied by 5/9. So it's actually a faster way of doing this question, and then when you press your calculator, final answer will be half. So there you have it.